Okay, in section 8.6 we're going to be adding radicals, and in order to add them they have to have the same order, the same index, and these two both do have the same index. They also have to have similar radicals, meaning if I had 2 times the square root of 5 plus 9 times the square root of 5, I could add those two because they both are attached to similar radicals. Like in problems where you've seen the ones where you have like a 3x plus a 4x plus a 1y. You can't put the y with the x's, but you can put these x's together to make a 7x. You can put these ones attached to the same radical, the same square root of 5 together. 2 square root of 5 plus 9 times square root of 5, that'll be 11 times the square root of 5. You can add things with similar attachments. So these two, that's 1 times square root of 48 plus 1 times square root of 108. You can't add them. You need to simplify them down. So let's do that. 108. Let's see how we can break that down. 27 goes into 108. I know. I'm not sure how many times. Let's see. 108 divided by 27 is 4. Okay, it goes in there 4 times. 108 is 27 times 4. And 48, let's try to break it down a little bit. 48 is 12 times 4. Okay, we may need to break it down even a little more to get it to come out of there. That may not have been the best numbers to choose. 12 is made up of 4 times 3 times 4. Okay. 27 is made up of 9 times 3 times 4. Okay, I've broken these down enough to see I can take this. This has a square root. This has a square root. 4 times 4. Okay, that could be 16. No, I'll rewrite that. 16 times 3. That looks better. I can take the root of 16. Okay, so go ahead and do that. The root of the 3 will stay under, but 16th root is just a 4. And over here, let's see what can come out. The 9. Square root of 9 is 3. It can come out. Square root of 4 is 2. And then my square root of 3 stays under. Cool, I've actually got 2 numbers. 3 times 2 is 6. So now I've got 2 numbers. Remember, we were adding them. 4 times the square root of 3, that's what square root of 48 came to. 6 times the square root of 3, that's what square root of 108 came to. Now I can add them because they're both attached to a similar radical. So you can add similar radicals. It will come to 10 times the square root of 3. Good. All right, let's do number, I kind of cut my 10 right there. Let's do number 3. The square root of 48 plus 18 times the square root of 1/3. Okay, let's break. Well, first let's get our 3 out of the denominator because we don't want a radical under there. So we've got square root of, I'm going to go ahead and break that 48 up in this step. 16 times 3, that's what 48 is, plus 18 times square root of 3 at the top and regular old 3 at the bottom. That 3 can go into itself 1 time. It can go into 18 6 times. So now when we come down, in this step, we'll let our 16 come on out and be a 4. That's the square root of 16. Leave the 3 under there. And in this one, we simplified 18 over 3 can just be 6 over 1. So plus 6 times the square root of 3. Cool, we have the same thing happen again. Wow, I did not know they were going to do that. 4 plus 6 is 10. And they're both times the square root of 3. So you keep that 3 attached for your answer. All right, let's try number 4. This one they do not have the same order. This is the 6th root of 16 plus the 3rd root of 256. All right, 6th root of 16, 3rd root of 256. We're going to have to take them out from under here, take them out from under their radical and make them into a fractional exponent. 16 to the 1/6 plus 256 to the 1/3. There we go. Now my 16, I'm going to make a parenthesis for it and call it a 4 squared. That is what a 16 is. And then still have my 1/6 on the outside. 256, I know that can be broken down somehow. I'm not sure how. With what? Let's see if 64 will go in there. That sounds familiar. Yes, 64 times 4 is 256. Let's double check that. Yes. So, oh wait, that didn't really help me. I need something to a power. Maybe try 16. 16 times 16, is that? Yes, that is 256. So there we go, that's to a power, 16 squared to the 1/3. All right, so now we can multiply out the exponents. 4 to the 2/6 and 16 to the 2/3. Now let's try to get these denominators to match, because the denominators, when we put them back under radical, that's going to be the index. We want the indexes to match so that we can add them. Well, the 6 really, actually look at that, 2/6 will cancel down to be 1/3, and then we'll have 3's for our denominator. So 1/3. Now we've got 4 to the 1/3 and 16 to the 2/3. Now let's put them back under there. 4 to the 1 with a cubed root, and 16 squared with a cubed root. Okay. Right now, I still can't add them because one's a 16 and one's a 4. How can I get my 16 out from under there? Well, let's break down what is a 16 exactly. I'm going to work that over here. Cubed root of 16 squared, that is 16 times 16. What if I broke my 16s down even more? Cubed root of 4 times 4, that makes up that 16, times 4 times 4. That makes up the other 16. All of this, if you multiplied it together on your calculator, 4 times 4 times 4 times 4 is, it'll come back to that 256 that we had in the beginning. So we're still on the right track. Cubed root of all of these. When you have a cubed root of something, if you had 3 of them, they could make it out of that radical, and look, we do. So cubed root, what we really have here is the cubed root of 4 cubed times that other 4. That makes 4 4s. But we separated it out because we want this to come out. I'm really working myself into a corner. I'm going to carry this work up to here. Just bear with me. Okay, so the cubed root of, that's really messy. Let's carry it up to here. Okay, the cubed root of 4 cubed times that other 4. That came from when we broke down all of our 16s like this. Okay, all right, so this one can come out to be a regular 4, and the other one stays under that cubed root. So now our 16 that we had down here, this and this can actually be added, because look, this one is a square root of 4 under a cubed root, a cubed root of 4. So our other problem was a cubed root of 4 plus the one that came from the 16s, the one that came from 16 to the 2/3, that is now a 4 to the cubed root of 4. So they do have different coefficients, this 4, and this one has a 1. It's divided so we don't mix up this problem with the other stuff. Those are old problems over there. But we have a 1 times cubed root of 4 plus a 4 times cubed root of 4. We can add the coefficients. 1 plus 4 makes 5 times the cubed root of 4. There you go.